I am Anil Kumar. Welcome to my series on parametric equations. In this video, we are going to explore in details what parametric equations are, how are they related with Cartesian equations, and how do we find domain and range. All these discussions will be with my student Amy from UK. Our approach, engaging minds, connects learning, visualize solution, evolve strategies. You can join my classes by sending an email on the address given. Creative thinking and problem solving is the main objective here. Let us now enjoy the lesson with Emmy. Hi, Emmy. How are you doing?
Hi, sir. Yeah, I'm all right. Thank you. How are you?
Very good. Very good. So the year is coming to an end. What is the position now?
So I think in terms of exams and things, we've got mock exams, which are in February, and then we've got our real official exams, which are in May. So I guess, yeah, it's kind of been continuous revision until then. But I'm prepping now. I've got 4 weeks till the maths exam, which will consist of everything, from year 12 to year 13. We haven't had that many in between tests like the previous years due to all the COVID and everything, and working online as well. So every test that we do, like any unit test, they are like taken to like such an importance, just in case any major lockdown will come up. They take those into consideration. But yeah, I guess the main thing is now trying to prep for this big exam, because it's going to consist of a lot of topics, the whole year and a half's worth of content. So I know I've slowly like forgotten, and so we're trying to get back into that and revise topics. So
Tough for you. Here in Canada, we have semester system. Just a couple of months course will be there in the exam, and
yeah, I really wish we had that system here. So much harder here, because especially even if you know the content, it's just in the moment you forget, because you've done it so long ago. It's so hard. So yeah, now I wish it was in Canada. Yeah.
So today, what do you want to learn?
I was hoping if we could go through parametric equations.
Parametric equations. I love this topic. Actually, it's quite complicated but interesting. So why don't you share what you have, and then we can go from there, and I can share with you what I have on this topic.
All right.
So you can share your material, and then we'll begin our class on parametric equations.
Cool. So
yes,
yeah, we were doing a couple, questions. I did like the idea of making, the Cartesian equation and, changing up in that format. But yeah, there were a couple questions that were slightly tricky. So
that's beautiful book. Your book is pretty good, actually. So colorful and all. It looks nice.
Yeah, it's appealing to the eye. That's for sure.
Yeah. So let me first tell you what parametric equations are, and then from there we'll begin. Is that okay?
Yeah.
Okay, let us also see what type of equations you have there. So example 1, let's go to example 1. What type of equations there? X equals to 2t, y equals to t squared. So that's kind of a parabola, right? Which they have sketched here, perfectly fine. And then we have x equals to ln t plus 3, y equals to 1 over t plus 5. So that's a beautiful exponential equation, correct? Very good.
Yeah.
We'll see how to work on this. Next example.
Oh, there was only two.
Then the exercise. Oh, great. So let me give you some concepts, and then we'll come back to your examples and exercise and do some questions. Does that sound good?
Sounds great. Should I come off the screen?
Yeah. So let me share whiteboard. Let's make things very simple.
So, basics would be great. This is a new topic for me.
What are parametric equations, right? We're talking about parametric equations, right? It is always better to connect with what you really know, right? And then get to the new stuff. That's what I always prefer. what
Yeah.
you know is Cartesian equations, right?
Yeah, I haven't heard that term before, but apparently we've been using it all the time. So
You are so right.
yeah.
So only when you get introduced to the new thing, you know what good things you had earlier.
Yes, that's so true.
So now see, we were all along working on this plane, which is also called Cartesian plane, right?
Mhm.
So on the Cartesian plane, while we had been working on, we have one axis which is x, the other one is y. Independent variable was x, and y was your dependent variable. And let us say you have a circle. For example, let me just sketch one circle here. I actually love to sketch circles, and this is not so good, but it will serve our purpose at least.
Mhm.
So, so we have a circle here, and we know what the equation of a circle is if we have center at the origin. If there is a point P, in that case, we can say, let's say this point in general is xy.
Mhm.
Now, equation of circle in Cartesian form, as you know, is x squared plus y squared equals to the radius squared, let's say r squared, right? Where
Yeah.
r is this. So that becomes the equation of the circle. And when you started learning this particular equation, then I hope you remember that you basically dropped a perpendicular from here and then use this right angle triangle to get the equation, because
Right.
this is x and this is y, correct? So at that time, you related r with x and y, the Cartesian points on this, right? You said, well, this is Pythagorean theorem and makes sense. X squared plus y squared is r squared, right?
Yeah.
Plus that. And that becomes the equation of the circle. And then I hope you also remember that when you went to trigonometry, you said, well, if this angle is theta, then what? If this angle is theta, then you say, well, this is my adjacent side, and that is the hypotenuse. And we know what cos theta is, right? So you said cos theta is x over r, and therefore you could write r cos theta as equal to x, correct?
Yeah.
Similarly, you said, well, sine theta is equal to y over r, and that means r sine theta is equal to y. And at that stage, you change this equation to in this form, and then you say, well, the point now, x and y values I have, and their values are r cos theta and r sine theta. You see that?
Mhm.
And as soon as you gave that value, this coordinate system changed, right? Because now you have theta involved in it, correct?
Right.
And
Right.
you call this as a polar equation, right? Because
What the r
now,
cos theta and sine
because
theta.
r and theta, r being the radius and theta being the angle, you could find any point on this plane, correct?
Mhm.
So with the help of radius and the angle, you can look at any point, right? If there is a
Oh.
point here, I could say this is r1 and this angle is theta1. You get the idea.
Yeah. Yeah.
So you all of a sudden use the same, we had been using this Cartesian coordinate system, but we had been using it in many different ways all
Mm.
along.
I see.
As you can
Yeah.
see now, we use it for polar, right? Some of you who did complex equations, they also used y-axis for I, right? You remember that part?
Oh yeah, for vectors.
Vectors for
Yeah,
vectors,
I and j.
I and
Right.
j. So let me write that also here, just to remind you that it's not a new thing, right? You had this unit vector I and you had unit vector j, and they said, well, now this is a complex plane, right?
Yeah.
So you can visualize for yourself at the moment that the same plane with which you are working, you are giving different names
Mm.
depending on what you put on each axis. Simple as that.
Right. Yeah.
And so, not surprisingly, we are now with a new type of equation which is called parametric equation, right?
Yeah.
The term parameter we used earlier also. In polar equation, r and theta are two parameters. These are actually parameters.
So X and Y aren't.
X and y are also parameters.
Oh, okay. Yeah.
R and theta are also parameters. So whatever these variables are, we normally say they are parameters, or they are also attributes to define something.
Right.
Yeah, but for convenience and for giving, for removing the ambiguity, we say, well, this is Cartesian plane, this is polar equation, this is complex plane, so that we know exactly what we are talking about.
Right. Yeah.
So similar is the case with parametric equation. Let me clear the screen. Okay, all this is clear to you.
Yeah.
So
Yeah.
parametric equation is not new to you. You know
No.
r theta and x and y you already wrote in terms of trigonometric functions. You get
Right.
the
Right.
idea? So let's
Yeah.
get back to parametric equation just to make you comfortable with it.
Wait. So is Cartesian, form just writing things in terms of X and Y?
Yes.
Oh, okay. So is Cartesian like a person or
Yes,
just a
yes,
name
yes.
of a thing?
He
Oh, it's a
developed the
person.
system. Yes, yes. It is to honor
Oh,
his name. Yes.
okay.
So
I
now,
see.
yes. So now I'll give you another example, which you works normally with. Yeah, I mean, all quadratic equations when you did, you wrote something and you said, well, now I have something, and that is that I have a parabola. And if I throw a stone, it goes like this. Correct?
Yeah.
You say right. And what is this? You say this is height and this is time, correct?
Yeah.
And you have your graph, which is kind of like this. The same graph, you also said, well, this could be distance d, and with the distance, we are finding the height, correct? And you came up with the equation that h of, let's write t for now, minus 4.9, which is half of gt square, right? Plus initial velocity times t plus initial height, correct?
Yeah.
You gave this equation, which is the parabolic path when you throw a stone or when you're talking about something which is actually traveling in time. You see that part?
Yeah.
Which is actually traveling in time. So I could, at any instance of time, if I relate this with x and y coordinate, let's say this is my y coordinate and this is my x, I'm just superimposing the same thing, coordinate system on it.
Yeah. Yeah.
I'm saying, well, imagine that I throw something vertically upwards. So I'm throwing something vertically upwards, straight up. So this stone I'm throwing up with the velocity of v0t upwards.
Yeah.
However, it will just go up. It will go up and come down. Is it okay? Same stone, correct? Because there is no horizontal velocity to it. It goes straight up and comes
And
straight
down.
down.
Right.
However, the time is moving. The
Oh,
time
yeah.
is moving, and therefore, if I have to check the height of the stone at different instances of time, it looks like this only, correct?
Right.
Because the time has moved, stone might have dropped at the same place, being at different heights, at different instances
Oh,
of time. You get the idea?
right. Right. Yeah.
So, strictly speaking, we are again talking about the third parameter, time in this case, correct? Not
Yeah.
just distance and height.
And height. Yeah.
Correct. So that means whenever we are working with real life situations, definitely there are more than two parameters, or more than one for sure, but more
Oh,
than two parameters which we are normally working with.
right. Yeah. So
How
yeah,
do we
more things
relate those
playing.
parameters? And that
Yeah.
is where the parametric equations come very handy. They are very
Oh,
flexible.
I
You get
see.
the idea?
Right. Yeah. Yeah.
Okay, so let's erase this page and get to parametric equation finally. Okay.
No, no, it's good to understand like the practical application because now like that's stuck in my head. I can really understand because it's nice to know exactly why these things are even there in the first place. So
Yes.
yeah, that's really important. Yeah.
Whenever you have a particular application, what are we trying to do as mathematicians? We are trying to model that situation,
Yeah.
analyze it, and predict what is going to happen.
Right. Right.
Correct? That is our work.
Mm.
So depending on the situation, we might have to make a new plane, for example, new axis, new coordinate
Yeah,
plane,
yeah.
and to work on it, maybe a new system to
Mm.
solve it, correct? So that is where these different kinds of equations work.
Right. Yeah.
So now what we are going to do is, since we are very familiar with Cartesian plane, we will actually kind of marry Cartesian plane with parametric equations. So let's call them as Cartesian equations. Is it okay now?
Yep.
So since the examples which I saw in your book, they were all relating x, y, and t. So we will, for now, to begin with, limit ourselves to x, y, and t. But it could be any three parameters. Is that okay? So we could say, let x, when I say x now, because I'm talking about Cartesian plane, I'm saying something along the x-axis. Is that okay?
Yeah.
Let us take the example of throwing the stone, and it is covering some distance with time, and let's say the velocity is something. Let's say it moves along the axis with respect to time as, let's say, t plus 1. Let's keep it simple.
Mm-hmm.
And we also know it is going up with time also. So let's say it's going up with time with 2t squared, right?
Yeah.
Something. So we have written both x and y in terms of another parameter t.
Yeah.
Necessarily, t is not time. T is, we said t belongs to real numbers. T could be anything.
Right.
T could be anything. So t belongs to real number. Let us say we say t belongs to real number and it is confined from, just to keep things simple, from, let's say it has these numbers 1, 2, 3, and 4. Let's say t has got only these 5 values 0, 1, 2, 3, and 4.
Mm-hmm.
Correct? Now see what happens. If I make a table of values, so I have different values of t. T is my parameter. Okay.
Yeah.
So t values which I have is 0, 1, 2, 3, and 4. For each t value, I could actually get corresponding x and y values. You see that?
Right. Yeah.
I could get x and y values, and we say, well, the x value for me is, just add 1 to the t value. So I get 1, 2, 3, 4, and 5. I added 1, right? This equation.
Yeah.
And for y values, I'll square and multiply by 2. So 1 square times 2. 2 square is 4. 1 square, I mean, sorry, this is 0. Sorry, I multiplied.
Oh,
Okay.
yeah.
T is 0. So now 1 square is 1 times 2. 2 square is 4. 4 times 2, 8. 3 square is 9. 9 times 2, 18. And 4 square is 16 times 2, 32. Is that clear to you?
Yeah.
So I've got x and y values. Now I'm saying, let me put this equation, which I'm calling parametric equation. It is written in terms of a parameter t. T is the parameter. In terms of which we have written the equation. You understand?
Right. Right.
Just as in the polar coordinate, r and theta are parameters. We are writing equations in terms of r and theta.
Yeah. Yeah.
Now t is our parameter. We are writing x in terms of t, y in terms of t. So if I have to plot this equation, what will I do? I know when t is 0, x is 1 and y is 0. That means there is a coordinate point 1, 0, right? So
Yeah.
let's say at 1, I have a y value of 0. Is that okay? But when x is 2, y is 2. So at 2, let's say y is 2 and this is y value of 2. Is it okay?
Mm-hmm.
When x is 3, y is 8. So this was at 2, at 3, y is 8. Let's say this is 8 for us. And when x is 4, y is 18, right? So 1, 2, 3, and then I have here 4. And at 4, sorry, I think I missed it. 2 was 8. Oh, okay. At 4, it was 18. Yeah. At 4, it is 18. So it is way up, right? So maybe somewhere here. So let me stop it here, right? At when x is 5, when x is 5, then
It's
it is
32.
32. It goes out of my scale.
Yeah.
However, I do have some points here, which I like because these are discrete points, right? I'm not connecting them with a solid line, but yes, I could connect them with a dotted
Dotted.
line. Do you see it's a parabolic in nature?
Yeah. Oh yeah. Hmm.
So on the Cartesian plane, what I see is a parabola.
Right.
And how do I plot it? I plot it for different values of t, which is my parameter.
Yeah.
Giving
Yeah.
different values of t will give me different values of x, y. Since I'm plotting it on a coordinate Cartesian plane, I have those points on x and y axis when
Mm.
Cartesian plane, and I could connect and relate with the equation what it is because I'm so used to Cartesian plane, right?
Right. Yeah.
I know this represents a parabola. I can see that, correct? That's what it is, right? You understand? So here we have learned a couple of things. One, how a parameter t can be used to provide points on a Cartesian plane.
Yeah.
How we can write independently x in terms of t. See, now x is not an independent variable, correct?
Yeah. Yeah.
X in terms of t, y also in terms of t. Both
Right.
are not dependent on t, correct?
Yeah. Yeah. So they're independent, to start off with, but now, with the Cartesian rule, they're both dependent on t, and that's how we've plotted our
So
coordinates.
t is the only parameter on which they are dependent. Can I say
Right.
that?
Yeah. Yeah.
T is the only parameter on which they are not dependent, correct? If I
Yeah.
fix the value of t, both x and y are fixed.
Yeah. Yeah. All right.
So that is the parametric equation, right?
Yeah. It's like
As
dealing
it
with
is,
one but taking care of two. Yeah.
yeah. So
Mm.
from here, now see the interesting part. I told you that t can have only these values 0, 1, 2, 3, and 4, correct?
Yeah.
We are now, when we talk about it, looks like a function to us, parabolic function, right?
Yeah.
Whenever
That's
it
been
comes,
like shifted.
yeah, whenever it comes to parabolic functions, the only thing which comes to our mind is what is its domain and range? Okay, right now. Yes, nothing else.
So I
Nothing
think
else.
that's with you when you see graphs. You're always
Nothing else.
thinking
Only
domain.
what is domain and range. I mean, we are not bothered about anything else. Domain, range, and then the chapter is over.
Yeah. That's true.
Why did we do this chapter? God knows. This chapter has got huge importance, right? But we'll
Mm.
restrict ourselves to domain range. We'll do that.
Right.
So, tricky part here is domain is not the value of t which I gave you. Correct? When you have converted to Cartesian, so when we take domain range, then we are talking about the Cartesian equation. So, what is the domain and range when we have worked with this parametric equation with this Cartesian conversion? You get the idea.
Yeah.
So,
So,
what you notice here is the x values. You see these? That becomes the domain right now.
oh yeah. So x is between 1 and 5.
So, that means it is actually speaking the output of this equation. Is it okay?
Mm.
Where the parameter t was 0, 1, 2, 3, right? So,
Right.
so the domain is basically range range of x. Range is output of x, correct?
Oh. Yeah. Because the y value. It's like,
Because
because the x is there, it's getting confusing. But yeah,
so the
the
values of
range
x
is
which
an
you
x.
have got now are actually the range, the output which you got for x when t was substituted with its
Mm.
values. You get the when the
I see.
parameter was put in. So the domain of a parametric equation is actually range of x.
X.
And what is the range? The y values, of course. So it is the range of y.
Yeah.
You understand this part. This is very critical.
Wait. The range is the range of y.
Correct. Now, if you look at the parabola, what is the domain? 1, 2, 3, 4, and 5. Correct.
Mm.
And what is the range? 0, 2, 8, 18, 32. Output.
Yeah.
So the range is the range of second equation, which is y equals to 2t squared.
Oh, okay. Yeah, yeah.
So you can say domain is the
Range of
range
X.
of first equation, which was plotted along the x-axis as
Yeah.
Cartesian parameter, right? And range is the range of y equation, which was plotted along the y-axis. You get the
Yeah,
idea?
yeah.
Does make
Oh.
sense to you?
Hmm. I thought you were going to do something like make an equation where you're putting x and y into one equation and then finding domain and range of that equation.
We'll do
But
that.
this
We'll
one
do that.
is,
This is
oh,
this is like clear. Is that
yeah,
clear?
this is really clear. That's why I thought
Yes,
this was
this
the only method I want to use.
is
I love this method. Yeah.
correct, correct. We will do that also.
Interesting.
We'll do it in a minute, okay? Let me have a
So
fresh
that
page.
sounds tricky. This one's
So
nice and clear.
just
Yeah.
remember this: x equals to t plus 1, y equals to 2t squared. I'll go to a fresh page, we'll redo it, right? Nicely
All
now,
right.
neatly. Oh, very good. X equals to
X
t
equals to
plus
t
1,
plus 1.
y
Y
equals to what?
equals to
2t
2t squared.
squared. Perfect.
Yeah.
So let me just build here what we had done. I took very simple values only, So we took t values as 0, 1, 2, 3, 4, and x values were one more than this 1, 2, 3, 4, and 5. And y values were double
0 to
0 and double
2,
it and
18, 8,
8, 8. This is
8,
8, right?
yep, 8, 18, and then
Very good.
32.
Correct. So we had all this. Now, I mean, as you were saying, we can actually write the parametric equation also. Let's do that part. And which is, we know x is equals to t plus 1, correct? So what is t equals to? X
X
minus 1
minus
is
1.
equal to t. Perfect. We say y equals to 2t squared. So what is t for me? X minus 1 and done. So we get this equation. You get the idea.
Hmm.
We
Subbing it
substituted.
in.
So first, isolate t. Second,
First,
you got this t, right? So we got this equation 1, right? Then substitute in y. Is it okay?
yeah.
Simplify. And now you know your equation. And so what are you going to do? Well, we love this Cartesian plane. We'll do this.
Sketch.
We'll just plot these lines. Well, the values
Sketch
are
the
already
graph.
there. So if I substitute, we know t was given to us as 0, 1, 2, 3, and 4. And so we got the values of x and y. So I cannot take any other value of x. I could take only 1, 2, 3, 4, and 5, right? So 1,
Yeah.
let's say 2, 3, 4, and 5. I know it's parabola, right? So I just taken all these. Not to the scale, of course, but just to give you an idea that this is what x and y is, because it represents the value of y, which is equals to twice x minus 1. It's a parabola. Shifted 1 unit to the right, correct?
Mm.
With a stretch factor of 2.
But you know those values of t, do we don't sub in those values into the y equals 2 because that only x and y are given.
Yes, because we have substituted the value of t, because now you know what is the domain of this function? X belongs to only numbers 1, 2, 3, 4, and 5, because t was restricted to 0, 1, 2, 3, 4.
Oh.
Therefore, I again have a scatter plot, correct? And now you know what is the domain of this function. Domain is 1, 2, 3, 4, 5, and range is the y values, correct? The same result which we got earlier.
Yeah.
Do you understand?
So two
And
methods. So sketching, graphically solving, and then also the algebraic side.
any equation is there. What you have to do is isolate t from the x equation, right? Because when we are trying to relate, we want to make x as our independent variable and y as my dependent variable. That is We had been working for 12 years. I mean, in the school, right?
Yeah.
Exactly. We don't want to change that. No, no, we'll not change that. We will come back to the same thing. So we'll isolate t, put it in x, and get the y in terms of x. Now we are comfortable. Is that
Yeah.
okay? Now let's open your book and answer all the questions. Okay?
All right.
Good.
Okay.
Did you
So
understand all this? First
yeah,
thing,
that
can you
was
summarize, Amy? Can you summarize what you learned so that we can just open and just go through the book without any problems? Yes, tell me.
yeah. So we started off with understanding the Cartesian equation and kind of how it derived initially. So it's basically, using the coordinate plane that we've kind of always used, but relating two terms that were independent of one another. But because they're both dependent on one parameter, like we saw in the equation t, it's relating the two in one equation. We saw how to solve that graphically, which is by doing a quick sketch and plotting the different variables and showing the different coordinate points on the axes, and then we showed it graphically by so first we're isolating t, substituting that into the y equation, and then simplifying further, and then from those two equations we got the same answer, but just trying to show the different like methods and approaches. So yeah, and usually with these parametric equations they involve two or more parameters. Yeah, that's what we've seen.
This is very useful when you get to multivariable. When you go to calculus, now you can see how easily you can write one variable, second variable, third.
Right.
U, V, S, whatever you want to use, you can use as a parameter and relate one after the other all the equations. You get the idea.
Yeah, yeah.
That is the power of this exercise which you have done, right? Okay, so
Yes.
let's
It's
see
very
what's
effective.
in your book now.
All right. Should we? So, do you want me to enlarge it slightly, or is it all right?
Yeah. Okay, no problem. So let's look into the first example. What are they talking about? Okay, read this bold thing. Right? Let's read what is there given in bold, right? Okay. So okay, read this. What is given here?
A
Please.
curve can be defined using parametric equations: x equals pt and y equals qt. Each value of the parameter t defines a point on the curve with coordinates pt and qt.
Right. Exactly. They have written x comma y. Do you see that? Because
Right.
x is defined as a function of t pt and y is a function of q qt. You get the idea?
Yeah, yeah. So that's
So,
what. Yeah, that's exactly what you mean.
It may look like a very complicated thing. No, no, no. X is p of t, y is q of t, and therefore coordinate x comma y is same as coordinate p function of t comma q function of t. Is that okay now?
Yeah, yeah.
Good job. Now let's read this second bold stuff.
You can convert between parametric equations and Cartesian equations by using substitution to eliminate the parameter.
Correct. Third.
For the parametric equations, x equals pt and y equals qt. With the Cartesian equation, y equals fx. The domain of fx is the range of pt. So that's what you're saying, the range of x. And then the range of fx is the range of qt,
range of qt, which corresponds to y. You understand?
Right.
So whatever goes on the independent variable side contributes to domain even now, because it is not just x, but a function of some other parameter. That's output will become your domain. Is that clear?
I see. Yeah.
Y is now not just y. It is a function of another parameter. Therefore, output of that function is going to be your range.
Yeah.
So now again, please read this is very tricky. So please read it again.
So for parametric equations, x equals pt and y equals qt, with the Cartesian equation equaling y equals f of x. So the domain of f of x is the range of pt, which is x, and then the range of f of x is the range of qt, which is y.
Is that clear to you?
Yeah.
Very good. Let's see the example.
Example 1. A curve has a parametric equations of x equals 2t and y equals t squared, where t is in between -3 and 3, not included. Part A, find a Cartesian equation of the curve in the form y equals fx.
So you'll isolate t, substitute in y, and then you get your equation. So read
Simplify.
step number 1, x is equals to 2t. So that means t is half of x. Now
Yeah.
we're substituting this half of x in y equals to t square, and we get x square over 4 as our function. So it's a parabola with a compression of 1/4, right?
Right.
Important thing here is look at the domain. Let me write it bigger. So t is given to us between -3 to 3, correct? That means 3 is not included. You get the idea?
Yeah.
So you'll get a hole there, right? So when you sketch a graph,
Mm.
that point should not be included in your graph or in domain and range also. Is that clear to you?
Right. Yeah.
Now let's see the solution. Because then they have sketched the curve. Let's go through the curve and then we'll do the exercise. Yeah. Next page, please. Yes.
So part B will state the domain and range of f of x.
Correct.
And then sketch it. So yeah, so what they've done there.
So t is between -3 and +3. So when t is -3, then you plug it in and get the value of x. That part, then you get twice -3 is -6, right? And twice 3 is +6. So it is between plus and -6, and these are not included, correct? So we have a whole.
Oh, right.
That becomes the domain of your function. Is that clear to you?
Yeah.
For range, plug the value of t in y. But remember, this is a parabola. So when you plug it in, the center value will be the minimum value, right? So you have to be very careful. So when you do -3 whole square, you get +9.
9. Right? Yeah.
And +3 also gives you +9. However, you understand that if you plug it in between values, you will get a 0 also, right? Which is included.
Yeah.
So 0.
Yeah, like you can't write 9 to 9 like we did with x. Yeah. Yeah. So 0 is the lowest. Yeah, you won't see that if you just do like we did with the x one.
0 is included, but 9 is excluded. So
not included.
Not included. So remember this part. You have to be very careful when you look into what the parameter is given to you as. Is that okay?
Right. Yeah. But how come when they sketched it, they didn't put like the hole on the where the 9 is?
They actually have, but sometimes in the book when we print it,
Oh, it goes.
those things are like minute details are missed sometimes. Critical.
Oh, I see.
I should
Yeah,
say
just
critical,
checking, for
critical
exam.
minute mistakes.
Right.
But
so in an exam, I have to make sure there's a hole where the 9 is.
Very clearly open circle, okay?
Okay.
So you should draw open circle here for sure. But in the inequality, they have written. But in the inequality, they have written that y is greater than equal to 0 and y is less than 9, right? Clear. So this is very important, okay? Now let's go through the second example also, and then we'll take up some questions from your exercise.
All right.
Can you do
so
it?
example.
Yeah. You should
Sorry.
be in a position to do it, right? Do it. X is ln t plus 3 and y is 1 over t plus 5 and t is greater than -2, right?
Mm-hmm.
What will you do? Okay, first is find the Cartesian equation. How will you find the Cartesian equation? Tell me.
So this is isolating t first, substituting the value of t into y, and then simplifying.
Perfect. Can you please read part A?
So find a Cartesian equation of the curve of the form y equals f of x, where x is greater than k, where k is a constant to be found. Correct. And then part B, write down the range of f of x.
Perfect. So, as you said, x is equals to ln t plus 3. To isolate, you will take exponents on both the sides because these are the inverse. So e to the power of x is t plus 3. So you get t as e to the power of x minus 3, right? So that is what you get. Now, you substitute this value of t in y and you get y is 1 over t plus 5. And when you substitute e to the power of x minus 3, you get 1 over e to the power of x minus 3 plus 5. So in the denominator, you have e to the power of x plus 2.
Yeah.
Now, e to the power of x plus 2 is always positive, right? So this will be always positive function, right? E to the power of x is positive. Adding 2 is also positive. Is it okay?
Oh, yeah.
Okay. Now, what is this? Read this statement, please.
When t equals -2,
yeah,
x equals ln plus ln
plus
t
3.
plus 3 equals ln 1, which is 0.
So, it is always increasing function.
Yeah.
Natural log is an increasing function. So the minimum value is obtained by substituting t as minus 2. And when you do that, you get the value of 0. That means that the x value is always greater than 0. Is that clear to you?
Yeah.
Correct. So that is how they get the domain of the function. X value gives you domain of this function. Correct?
Right. Mm-hmm.
Okay.
And it's
So
only greater than, not equal to, because of
not
the
equal.
inequality
Yeah.
on the t.
So continue reading from here, the next para.
The Cartesian equation is y equals 1 over e to the power of x plus 2, where x is greater than 0.
Correct.
When t equals minus 2, y equals 1 over, so t plus 5, where they substituted the minus 2 and got a third. So as t increases, y decreases, but is always positive.
Correct.
So the range of the parametric function for y is between 0 and a third.
Correct. You get the idea?
Yeah, so for that one, did they, to find the domain, to find the range, you do the range of y.
Range of y. And because you're dividing by a positive number, right? So it is decreasing all the time. That positive number is increasing, right? It's an exponential function. Right? So it decreases, but it cannot go negative. It goes to 0, up to 0, not 0, right? It never reaches 0. It's to the power of x. Horizontal asymptote is y equals to 0. Is this clear to you? Everything?
Yeah.
Let's see a few questions from the exercise then. Okay. So take some examples from from question number 1. What does it say?
Question 1. So it says, find a Cartesian equation for each of these parametric equations, giving your answer in the form y equals fx. In each case, write the domain and range of f of x.
Perfect. So you can pick up one example. Let's take E, for example. This is slightly more difficult, right, than others. So from here, first step, you have to isolate t, right? So how will you isolate? Just cross multiply. So you get t minus 2 equals to 1 over x, and t is equal to 1 over x plus 2. Is that clear to you?
So just a quick thing, when you want to isolate t, does it always have to be from x you take, or can you do from y?
No. Y is your final equation. Y you have to write in terms of x. Because y for you is the output. When you write in Cartesian plane, x is independent. For you, x is the domain, kind of, right? And y is the range. And therefore, you should always write, if they specify Cartesian plane, it is assumed that y is the output and x is the input for that function.
I didn't think it mattered which one. Okay, I think that's why I was getting all my answers wrong. Because whenever I saw it like y looking easier, I just did y to y t. Like that. Oh, okay.
Don't go reverse. So now we got the value of t as 1 over x plus 2, and you can substitute this as y equals to 1 over x plus 2 whole square, right?
Squared, yeah.
And then you get your function. This is what. Anyway, so 1 over x square, you can write this as, right? Plus 2ab, 4 over x, right?
Yeah.
So you have this function in terms of y. And now you have to write domain and range. So domain is the output of x, correct? X is greater than 2. So this is a rational function. 1 over 2 greater than 2 means if it is higher number, it is going to decrease, correct?
Yeah.
But since it is positive, it will always be above 0, correct?
So we don't have to substitute a 2 or anything. We're just looking at the function and seeing.
You can substitute. So if you substitute, it is greater than, t is greater than 2, right? So if you substitute 2, you get a vertical asymptote, right? So the graph is kind of like this. Is it okay?
But are we substituting into the equation we just found?
No. We'll find the domain.
Oh, you're putting it into that one. Okay, yeah.
Domain is the range of x, correct? Don't
Yeah,
forget.
right.
So you see it's this kind of a graph. That means it is greater than, domain is, x is greater than 0. Is that okay?
Yeah.
Correct. And now you have to find the range. So range means now the output of all this, correct? You know now x is greater than 0. So x cannot be 0, of course. And if x is very, very high, all these numbers are 0. So minimum is 4 for you, correct?
Because yeah, +4.
X is
I'm
greater
just
than, yeah.
I'm just trying to understand the domain one. So when we substituted like 2 in there, 1/0, that's error. So that's why there's an asymptote. It's just we're saying x is greater than 0.
X is greater than 2 is your, t is greater than 2 is given to you, right? Parameter?
Yeah. Yeah, it's given.
So you have to go, so t in x, you are working on the equation x equals to 1 over t minus 2, correct? So if t is greater than 2, at 2 it is a vertical asymptote. If it is like 3, 4, 5, 6, 7, higher the value in the denominator, lower will be x. If t approaches infinitely large, if t approaches infinity, then x approaches 0. You get the idea?
Yeah.
So it started from positive infinity. Now it's getting down to 0. So all values above 0 becomes your domain. Is that clear?
That's clear. Yeah.
Now y equation has 1 over x in it, plus 2. 1 over x plus 2. So if x is very, very large, 1 over x will be 0. And you're left with what? 2 square.
Yeah.
2 square is 4. So the minimum value which y1, if x is very, very large,
is 4.
Is 4. If very, very small, then it is infinitely large, correct?
Yeah.
Because 1 over x very, very small, dividing by 0 gives you infinity. So it goes from 4 to infinity, right?
Yeah.
Of course, 4 is not included. So y is greater than 4. Does it make sense to you? Y
So when finding the range, which would be the range of y, we're not substituting the 2 anymore. That was just for x.
Yeah,
to find y, so to find the range of y, it's just completely independent. It's like you look at the equation and try and solve.
Okay, but you're not wrong. You have this equation. Let me write here. Y equals to t square minus 1. Is it okay?
Yeah.
Now t is greater than minus 2. You said, right?
Oh wait, that's a different question, I think.
No, I'm not doing that question. I'm answering on this side.
T squared minus 1. I think that's the above question.
Let me erase. Now, why is t squared minus 1? Is that clear to you?
Yeah, but so, wait, are you doing a different question?
Oh, sorry. Yeah.
Okay. I think it's t squared. Yeah.
This question, right? Okay. So let me erase this. So we have y equals to t squared and t is greater than equal to 2, correct?
Yeah.
Range of the function is directly dependent on y. So if I substitute 2, what do I get? Not greater than equal to, is greater than, right?
Greater than, yeah.
So that means y is greater than 4, correct? So that is my range. Direct.
Oh, so when you said 4 then to infinity, that's just, infinity is greater than 4. You don't need to do any other, you don't need to include infinity somewhere in your answer.
Correct. And you could directly go with this equation also to find range of x will be the domain, right?
Yeah.
Substituting this. So the final Cartesian equation is not required.
Oh, but that helps
you. Cartesian equation is a part of the question. You have to derive it. That is all.
Yeah. Oh, I see.
But once you derive it, you have to write the restriction. Don't forget that. That x is greater than 0. Is that okay?
That's clear. Yeah.
That is important. So finding domain and range is independent of the Cartesian equation which you derive.
Okay, I see.
You can do directly domain range straight, then do the Cartesian equation if you want to.
Oh, okay, yeah. Yeah, maybe I'll do that because when I see, so many equations, I'm just thinking where am I subbing and which range and domain am I taking?
Yeah, I see. Now read your question once again. Okay, so read it, please.
So find a Cartesian equation for each of these parametric equations. Giving your answer.
Wait. Because the book writes find the Cartesian equation first, right? So what a
Yeah.
student is going to do? Find the Cartesian
Find
equation.
the equation. Yeah.
Now read the question further.
Then it says, give your answer in the form y equals fx.
Yeah.
And then in each case, write the domain and range.
Of fx. See, this is cunning.
Oh, is fx the Cartesian equation?
Find the domain and range of f of x, which is a part of Cartesian equation. Do you see that part?
Oh, so it has to be done in that order.
No, it is immaterial. I mean, because
Oh,
we know that the Cartesian equation, whichever you derive, I'm just telling you why. If you derive a wrong Cartesian equation, then you get second part also wrong.
oh yeah. Oh, so it's better to have that in like like those if A affects B in part C like that. If you can do
Yes,
B and C, don't let A be the one that stops you. Yeah, I see. Okay.
that is why I made you read this question twice. It
Right.
says find the Cartesian equation, then find domain and range. I do not read like this. You know what? I do not read like this. My English is not so good. I read in small phrases.
Yeah.
Find Cartesian equation. Good job done, right?
Yeah.
Find domain range. I know domain range I could directly find from the parametric equation. Why should I go to my complicated Cartesian equation?
Yeah. Yeah. That's why I was struggling. Yeah.
No, the whole idea of having parametric equation is simplify your function so that you can relate to small things and work out details.
Oh.
Why should I work with the complicated equation when I have
Yeah.
an option?
Yeah.
So my equation is very clear. X is equals to this 1 over t minus 2. I know this is a rational function. And if t is greater than 2, I know what this value is. I know x is greater than 0, right? Done.
0. Yeah.
Why will I break my head? No, I will not. Okay. Then I say y equals to t squared. It's a parabola, man. And if t is greater than 2, I just plug in 2 here, right? So it is 4.
Yeah.
Y is greater
than 4.
I'm done. So
Yeah, see, when I see it like that, I'm like, there's no confusion, straightforward. I understand it.
Full marks.
Yeah.
So first you get full marks for domain and range, then you worry about your Cartesian equation.
First you actually get full marks and get some marks, and then you worry about the confusion that they want to bring. Yeah, okay.
Don't
so then
fall
I'll do the
in the
Cartesian
trap
later.
of that. Find f of x and then find domain of range of f of x. No, man. It is same as my Cartesian equation.
Yeah, because what I was doing, like they say in the book, you find the Cartesian equation, then you find the domain and range of that. And I was like, but that doesn't make sense with the whole domain is the range of x and range of y, because I'm like, how did the Cartesian equation come in it? It's just parametric equations are independent domain range, then find your Cartesian equation, full marks. Okay.
Full marks. So
Got
range of x is the domain of your equation. Range of y is the range of your equation.
Range of y.
Done.
Yeah.
And those are very simple equations.
Yeah.
Why will I mix them up, superimpose, and then get into complications? No. Never. Okay.
That's so clear, sir. Thank you so much.
So likewise,
that would help me a lot.
You should go through all these examples. The second one, I'm seeing the same exponential function, right?
Yeah.
Natural law. So you follow your book example, you should be in a good thing. And in the next class, we'll continue from here. Is that okay?
Perfect. Yeah. So I'll attempt all these questions. Let you know if I have maybe any issues. But at this point, I feel like I won't. I definitely clearly understand like how to approach these questions.
So can you summarize in just few lines, like how should you approach these questions based on parametric equations?
Right. So as you know, as my book has kind of shown, it's they were kind of discussing to find the Cartesian equation and then find domain and range. But as we kind of discussed throughout the lesson, there was slight, confusion around it, and that's why I was really confused also at school. So since the parametric equation is already given, it's so much easier to find the domain and range of those parametric equations. So domain meaning find the range of x, and range meaning find the range of y, because they're given. then you would relate the two, since that's what the Cartesian equation is, and then you make isolate t, sub it into y, and then simplify the answer, and then you've got all the marks. It's that straightforward. And then if you need to sketch on the side, maybe a certain rational function or something, do so on the side. But that's so clear. Like all my doubts have gone out of my head. I was so scared about this topic. So thank you.
Let me remind you, when we were doing Cartesian equations, right? not by
Yeah.
that name.
Mm.
Then what was the first question? First question was find domain and
Domain and
range. Then do
range.
anything else. Follow the
Oh,
same principle here also for parametric equation. That is my
yeah. Why should
advice.
we change when we've already learnt it
Don't
like that?
change.
Right. That's so true. Thank you, sir. Yeah.
Okay, then bye. All the best.